know it's got to be around here somewhere. Well, there's a keyboard. That's in bad shape. Not in that box. Motherboards. Motherboards. None there. More motherboards. There it is. So why 6502? Well, you see, 6502 is the CPU that can be found on an old Atari 800XL board such as this one, which just happens to be in terrible shape. And if we look closer at the board, we see that there's quite a bit of corrosion, a lot of the components, some rust, some of the capacitors are in really bad shape and broken off. It's also missing the RF modulator, one of the joystick ports, and it's just generally in terrible shape. Thankfully, all the important components are still on the board, and because it's got the built-in ROM, if we can get this thing to power up and do something, you know, hopefully we'll be able to see something on the screen. And that's what I thought we'd do today. See if we can get this old, super crappy looking board to power up. So let's do it. This is a video that I was actually hoping to get out about a couple weeks ago when I actually hit 6,502 subscribers. Unfortunately, due to a series of unfortunate events, it ended up getting delayed, and here we are now. So just now I've checked the number on my account right at this moment, sitting at 6,548. So we missed the mark by quite a bit. Okay, so what are we looking at on the board? Well, we're looking at quite a bit. So as I already showed, and there's a little bit of corrosion like right around this chip here. We see that there's a capacitor missing at that spot. This capacitor is like in really bad shape, as well as that one right there. Thankfully, all the transistors that we can see on the board appear to be quite intact. They don't look like they have any broken leads. There's a little bit of rust right here, right around that chip. This potentiometer right there, that one looks like it's going to have to be replaced. So in case you're wondering how this board, you know, got to be in the state it's in, well, it's a bit of a long story, but the way this came about is when I was in middle school, my cousin and I were walking home from school one day, and we used to walk behind this Boys and Girls Club, and there was like a dumpster back there. Well, one day there was a bunch of old computer equipment that was getting tossed out, and then Atari 800XL being one of them. So my cousin and I, we collected some of that stuff and we lugged it home. Being the curious kid that I was, I liked to see what was inside of pretty much everything. And I used to just take like everything apart, you know, like wanting to see what was inside, seeing if maybe there was parts I could use. And so I ended up taking it apart, you know, taking stuff off it. Like I took the RF modulator off. I took off one of the joystick ports. I don't really know why or what I used it for. Thankfully, I didn't remove any of like the really important ICs. So all that's intact. And eventually, you know, this board just ended up getting tossed in with like all my other junk boards and stuff in case I ever, you know, needed to pull some part or something off of it, which thankfully I didn't do. The reason why there's some rust and some other corrosion and crap on it was because the last place we lived at, I had put some stuff in some boxes that I had stored like outdoors that I was going to be, you know, going through and like sorting stuff out, getting rid of some stuff. And I had them covered with tarp, but eventually the tarp kind of broke down, and then it rained and it got water on it, and some, you know, all this crap happened, and unfortunately this is what we ended up with. So yeah, that's why it looks as kind of crappy as it does. So one thing I've done already before we even start like working on it all is that I actually baked it for, I don't know, about maybe like 10 hours or so on my preheating infrared preheating plate. And the biggest reason why I decided to bake this before even trying to work on it is to remove a lot of the moisture that may have been, you know, like absorbed by the board. Because what happens then is if you try to like, you know, heat some part with like hot air or whatever, then it's more likely to delaminate due to that moisture, you know, trying to expand between layers of the board. And I just didn't want any of that to happen. Most of the stuff I'm probably just going to be hitting with like the soldering iron, not necessarily hot air. And it kind of smelled like, yeah, some like old kind of moisture sort of smells. but after a while it kind of just went away, so I'm kind of happy about that. It doesn't look like I need to do too much. For sure, maybe just replace these two capacitors right there. I have no idea what this value is, so I'm going to have to look it up. That capacitor there, I'm going to have to replace. And I'm not going to replace any of these with like brand new parts, because I can just probably pull off, you know, something from one of the other junk boards just to see if we can get this thing working and if it'll even output anything to the screen. The keyboard, while I do have it, that's one of those other things that really got like really badly water damaged, and a bunch of the keys are missing and stuff, and yeah, it's just not going to be usable at all for this. Thankfully, none of the traces look like they're broken, save for like this up here when I was probably trying to remove the RF modulator. It looks like I may have damaged these traces. Looks like they go down into this section. I'm gonna have to check the schematics to see, you know, what exactly does what, like what's for audio, what's for video. And looks like that should be it. If it works, that would be really cool. Not gonna hold my breath. So I think one of the first things I'm gonna do is I'm gonna spray this with alcohol, and I'm just going to give it a quick little wash just to get rid of most of that crap on it. Okay, so here's after the first cleaning. I've just cleaned it with some IPA, and it's looking a lot better already. It's really not as in bad shape as it originally looked, and if you didn't know any better, you probably wouldn't think there was anything even wrong with this thing. Yeah, no, that's a joke. You poor little old Atari 800XL board. Who hurt you? Oh yeah, that's right, that was me. I'm sorry. So I made a small list of all the capacitors I was going to have to look into replacing, and determined that a bunch of these are actually just for the power supply, and I will replace them just so we have like stable like voltage going through the board, so that fluctuations here like ripple doesn't make things act funky or anything like that, just to avoid any potential headaches due to that. But then two other capacitors, C23 and C49. C23, the one that's broken right there, that one looks like it's part of the audio section. At the moment, I'm not going to worry too much about it. C49, it's a 47 microfarad 10 volt rated cap there. It's an electrolytic. That appears to be part of the reset line, and that's this capacitor right there. And it turns out that these three up here were also for audio, so I'm not going to worry about dealing with those right now. I don't have a 47 microfarad like axial capacitor like that, but I do have these 100 microfarad capacitors that are brand new, so they have the leads that are still like long and uncut. So I'm just gonna put one of these. Basically what should happen with this one is that it's gonna take a little bit longer for the reset to like time out, but it's fine. I also managed to scavenge a few other capacitors from some other board that we are going to use to replace the ones that go along the power rail. If we don't get a signal or anything after applying power, a couple things I will check is, one is the reset right here at pin number 8 of this Schmidt trigger, the inverter I see right here, the 74LS14. The other thing we can check is the output at the oscillator section right here. This crystal right here on this schematic says 3.546894, but this is because it's a PAL version. I believe on this one we should be expecting the 3.579545 megahertz crystal. I've got all the electrolytics replaced, and I got the big one here that I said where it was originally a 47, now we got a 100. And up here I ended up putting a 100 just to prevent any sort of issues over here in the ROM area, because that is connected like over in this section. Everything else should be okay. I ended up putting a pot right here. Turns out pin number 1 on the RF modulator right here is the video that goes into the RF modulator. So I ended up just soldering in a potentiometer there with an RCA male. I'm gonna have to use a double female end to kind of get the other cable to hook up to it right there. But that's just soldered into the ground, and then the other one goes to the center of this potentiometer here. Potentiometer is just because I don't know the voltage level coming out or going into the RF modulator normally, so that way I can adjust it a little bit just to prevent hopefully damaging the monitor or anything like that. I almost forgot about the little potentiometer down here in the corner, but I ended up spraying it with some contact cleaner. I kind of worked it a bit, and then I ended up like trying to resolder the pins, even though they look pretty terrible. But I think it's probably going to work. Unfortunately, I don't have a similar replacement, and that's a 500K potentiometer. So, but if I hook it up here, can see that we're getting not what I was getting originally. Oh boy. I was actually getting a pretty good value there, but now I am not. See right there between the ground pin and the center pin, getting about 270 k ohms, but now between the center pin and the other pin I'm getting nothing. So this is probably not making very good contact anymore. No, it's not. Darn it. I'm just gonna pull it off, and I'll use 2 resistors, maybe like 250 k ohm resistors, and I'll tap the center to the pot there. It's probably gonna throw the colors off a little bit if we get anything on the screen, but it doesn't matter. I just want to see if this thing works or not. One thing that kind of sucks about this multimeter is that it's fast and everything, it's cool. The display has been getting dimmer and dimmer over time, and that's at the maximum brightness right there, and we can see that it's just not very visible anymore, so I'm a little upset about that. So this is what I ended up doing. My choices were either 220 or 270, and I had a couple of 220s, so I put those in there in place of the potentiometer, and I think that's pretty much it. So I think we're pretty much just about ready to give it a shot here. Is it gonna work? No clue, but all I gotta do now is apply 5 volts. Thankfully this rocker switch actually still works really, really well. I checked the continuity and it's like practically like nothing when it's in the on position. So that's off right there, that would be on. So I'm going to solder a wire down here to the ground, or where the ground would be, and then one to the positive. I'm actually going to hook up the multimeter in series with the power just so I can kind of monitor and see what it's using. If it starts getting like too high, the power supply is rated for 4, so if I see that it's starting to get like a little too high, maybe something's not right, especially if like nothing displays on the screen. All right, I got my power here. It's not actually plugged in yet, but I've got it going to the back of the board there, and I've got my video connector there going to the monitor, and I've got the multimeter here set to measure the amperage on the power supply. So I'm going to plug in the power supply now, but the switch over there is still off. And I'd be lying if I didn't say I was a little bit nervous, because like I said, this thing's been in and out of junk boards. It's been sitting outdoors for a while, and yeah, who knows what's going to happen. So here we go. Gonna flip the switch now. Hopefully nothing goes up in smoke. Click. 2 amps. Holy crap. Seems a bit high. Nothing on the display. Okay, let's shut it off for now. Anything getting hot? Not that I can tell, but I don't know how much this board is actually supposed to pull, like amperage wise. I guess I'll turn it back on and I'll turn up this potentiometer. Actually, I'll turn it up halfway now. See if that does anything, because I did have it like all the way, and if the display's not able to detect the signal there, it's probably not going to do anything. Here we go again. 2 amps. Wow. Still nothing. Well, the amperage just dropped a little bit under 2 there now. Yeah, I'm not seeing anything happening, unfortunately. I was going to say, let's check and see if anything here is getting warm, and I just turned this on, and this area right here where you can see that there's quite a bit of orange, that's all the RAM. So I hope there's nothing wrong with the RAM. But they all seem to be getting kind of like evenly warm there, so I don't know. Let's turn it back on and let's see what it looks like. Hopefully you'll be able to kind of get a good view right there. Let's turn it back on. Yeah, the RAM ICs are getting kind of warm, and so is this one, I think. Is that normal for these? Wow, it's like they're all getting warm. Remember how I said that if we couldn't get this thing to do anything, we were going to have to check the clock and the reset? Well, we're going to have to check the clock and the reset. So thankfully on the schematic here, we have the reset circuit, which is this area there. That capacitor, C49, is the big one that I replaced. That's right here. And this section right there, that's the clock circuit. So we're going to check the output and make sure that we're getting proper, like a proper clock signal to the ICs, because if we've got no clock, we've got no pulse. If we look down here at the board, there's a few little marks that I've made on some of the chips. They're kind of like just pins of interest. So I've marked them yellow and white. Well, There's white right there. There's yellow. So you can see we got another white one right there. So basically what these are is the white ones are part of the reset line. So the reset coming out of the chip right here, you see that I got a little white dot right there, goes to that one there, goes to over here and over here. So I'm going to check and make sure that first that I've got continuity to all those, and second that we're getting a proper reset signal. And then the yellow pins, as you can see, there's 3 of them right there. Those are a halt line that goes connected to all these ICs, and not exactly sure how important that is at the moment, but that's I thought it would be something that might be something important to check, so that's why I have those marked. And then the green marks, as you can see, those are clock lines. So we have our main clock that comes from up here in that section of the board. It goes into this chip right here, which is U17, and then from there, that's where it gets distributed. Okay, one thing I probably should have said, like from the very beginning, is that I've never repaired one of these before, and I really have like no experience fixing any of these Atari boards or a lot of like older computer boards. So pretty much everything that I talk about on this video is pretty much all I know at the moment. Everything that I'm kind of learning about it, you know, I'm kind of learning as I go, from like seeing the schematic and just like kind of looking up like general information about some of these ICs and everything. So I'm just kind of starting, you know, by checking some of the basic stuff, like we need to have a proper reset signal. We need to have a proper clock source. And if these 2 things, you know, check out, then we can start, you know, kind of going down the line. I already know that, you know, my power should be okay for the most part. If I were to measure the voltages at, you know, like various pins, you know, I do see that I am getting 5 volts. So I don't think we have a power issue at the moment. I think we have something else, you know, that's wrong. So we're going to start off by checking those 2 first. And to make checking some of this stuff easier, I pulled out some of the big toys, as you can see. Got the scope here, and we're going to be able to see the reset signal here. What we expect to see, and I haven't tried this yet, is we expect to see a rising voltage on this capacitor. And then we're going to probe the output of U19, which is the inverter gates right there. We're going to poke pin number 8, which is going to be the output. What happens here is the way this reset circuit works is this capacitor starts off with no charge, and once you apply power here between the ground and the 5 volts, this capacitor will start charging until it reaches a point where this inverter here triggers. The output here would be basically grounded, and then this is going to invert that signal, so this is going to go high, and that's going to pull the ICs here out of their reset state. Okay, here we go. And I'm just going to wait for the trace to finish, and I'm turning it on now. Stop. Alright, so here we can see that we hit the power switch. The voltage on that capacitor starts rising, and right up at this point, that's where the Schmitt trigger inverter pulls the chips out of the reset state, which would be down here. Okay, so the reset's working, but do we have continuity between that lead and the reset pins on the other IC? So let's check that real quick. And oh, I have my meter up here like on the Agilent little GUI thing, which I'm not too fond of. I don't know, the app kind of sucks. But because it's hard to see the display on here, I decided to do this. It's just kind of connected to my laptop here through Bluetooth. And that way you can actually see it more clearly here on the screen. So let's check that real quick. I just have it set to measure resistance. You can still hear the beep because I still have that enabled. But first we're going to check the reset pin here on U7. So, yep, we've got some pretty decent continuity there. Let's check it on U8, which is the CPU. So we've got continuity there. And let's check it on the reset pin on U23, which should be here. So yeah, we should have a reset signal then to all 3 of the chips that actually use it. Well, since the reset works, let's check the clock. So for the oscillator, we're looking at pin 3 of this 2N3906, which happens to be Q8, and that's the collector. So that line runs from that transistor all the way up to right here on U17 to GTIA, the oscillator pin. It also goes to this other chip right here, but that's only for the PAL version, which this does not have the chip for that. So we can basically ignore anything that happens there. So we're just going to focus on this right now. But first of all, I can check to see if I even have continuity from that transistor to the oscillator pin on the GTIA chip. So let's check that first. So we're going to check continuity between the collector and pin 28, which I have already marked. And we do have some continuity there. So the next thing to check is to see if we have a clock signal. You can see that we are getting a clock signal there, and I'm measuring it here at the chip of the GTIA. And let's see if we're getting anything out of this, because the oscillator pin is found right here on pin 28 of the GTIA, but it's got this phi 2 output that kind of goes off, and that's what kind of drives some of the other stuff. So let's see if we're getting anything out of that. I've already marked it here. That's pin 30. And there is an output there too. I forgot to mark the clock input on the 6502 CPU, but it's looks like it's pin 37 here, which is marked phi 0. Before it actually goes into the CPU though, it goes through a 74LS08, which is U18B, which is that chip right there. So the input, this is an AND gate. Looks like the two inputs from that come from U7, which is the ANTIC chip. You see right there it says phi 0. So we're gonna have to check both the input at that gate and the output going to, actually I guess I could just check the one going into the CPU, because if there's nothing going on here, then there shouldn't be anything coming out of it either. So yeah, we'll just do that. We'll just check pin 37 on the CPU, and there's a clock there, so that looks like it's working too. Alright, so I was starting to run out of ideas here. I didn't really know what else to even try to check on here that, you know, would give me some sort of clue as to, you know, what's going on. And then I thought, since we're not getting any video on the output, are we even getting any video out of the GTIA? And as we can see right here, we have a C-Sync line, we have a color line, and there's some luminance. And so I decided to probe the C-Sync, the color, and then some of these, just to see, you know, if there's like something going on in there that, you know, I haven't caught yet. Because if there's absolutely nothing coming out of any of these, then obviously, yeah, there's not going to be any video at all. But check this out. So first of all, we're going to probe the color line, which is pin 21 on the GTIA, which is this chip right there. So here's pin 21, and I'm going to power it up. And there's a clock. Oops. Right there. So that should be like the color burst, I believe. So let's turn this off so nothing gets too hot. And now check out the C-Sync. That's pin 25. So 21, 22, 23, 24, 25. Right there. If I could get it right on. Okay, there we go. Okay. We have something going on there. There's a pulse. So it appears that we are getting something out of here. I don't know exactly what, but something's happening. So this chip is working. Yeah, at least it looks like it's working. I can't say 100% for sure. So if we trace these lines and we kind of come over this way, we can see that a bunch of these lines, there's some pull-ups right here. There's like a 5-volt line right there. It says 5V/1. See, one thing I noticed is that there's different points here that label, like right here, 5V/2. And then down here, we're going to see a different one, 5V/4. So what they've done is some of the 5-volt lines that come out into the power connector, they sort of get split up. Like it's not one continuous like 5-volt line, like, you know, running all around the board. See, for example, like right here, 5V/1 right there, it goes through an inductor, and then, you know, it goes through some capacitors, and then it powers up, you know, like whatever is in that area. Well, let's check this chip right here, which is a self-contained. It's an N4050, but we see that we have VDD coming in here, and then we have our ground. But this VDD is basically this 5V/1, which you can't see. It's right there, goes through an inductor, and then we should have, it's at pin number, it's kind of covered right there, you can't really see it, but it's VDD's at pin number 1 of U20. So U20, so it's that guy. This is one of the filter caps that goes connected to it. And I had only just sort of like checked, you know, like voltages at some of the ICs on here. I didn't check all of them. Going to have the multimeter here on the screen again. Right now I've got the ground to the multimeter just tied to the ground at the power connector. We're going to check the voltage at this capacitor right here, which is C50. C50 is that one right there, and that's the one that I replaced down here. So let's check on pin number 1, or at the positive of C50. So right now we can see we have nothing because the power supply is not on. Watch what happens if I hit the switch to on. Yeah, there's like nothing there. And not only does this line, you know, feed that buffer IC, it also feeds some of this like amplifier stuff for the video. So if we have no power here, of course we're not going to have any video. So that inductor that we see right here, we have 501 coming into this inductor. This inductor should be the one that goes connected to the positive of C50 right there. So let's check what we have on the opposite side of that inductor, which would be this side right there. So let's turn the switch on. 5 volts. So apparently there's something wrong with that inductor right there, because on the other side we got nothing. I'm not going to have a replacement for that inductor, so I'm just going to put this little kind of like bead, little choke in here just in place of that one, just to get some power over to that section and see if we get anything out of the video output. Alright, so let's see if we're getting power to this side of the board. And 5 volts. Cool. Alright, let's see what shows up at that video output. Yeah, there's something there, but it doesn't look like doesn't really see a whole lot happening there. But let's see, let's hook it up to the monitor now and see what we get on the screen. I don't expect to get much, but let's just see what shows up. I've got the RCA plugged in there. We're hitting the power switch now, and oh, the little symbol came on, but nothing but a black screen. Well, since that got us nowhere, but it looks like there is some sort of a video signal being output. I'm going to see if this thing maybe will boot into diagnostic mode, because apparently from what I found out, it's got some built-in diagnostics, and on the keyboard you normally have to push the option button, but yeah. So we're going to try shorting 18 to 22 on the keyboard connector over here, which should be pretty much identical to just, you know, pushing the option key. Okay, I had to fight that a little bit to get it to stay, but it's in place now. So let's see what happens. I'm going to probe the video signal here, so we're going to be able to see that on the scope, just to make sure that something, you know, is being output. And here we go. Power on. We have there's a signal there, but doesn't look like anything useful. I've been at this for a few hours now, and I've come across two things. One, I didn't need to have the composite signal coming from the connector where the RF modulator used to be, but the trace that actually goes to the connector in the rear that's meant for the monitor, it actually is composite video according to what I found, so it should be fine at that spot there. And at one point when I did turn it on, I got like a scrambled sort of image-ish looking thing, but I mean, I couldn't really make out what it was or anything, but there was something on the screen, so it looks like the video section does want to work, but it's just not displaying anything. Some of you guys were probably from the beginning like, that's the wrong place to get the video signal, you know, and I had no idea. So at least that part, that should be okay. If it was working, you know, that should be a good source of video there. The second thing, and some of you were probably, you know, like yelling this out from the get-go, and I had no idea because, like I said, I've never messed with one of these things. But do you remember more towards the beginning of the video when I said that the RAM chips were getting really unusually warm, and I wasn't expecting them to get so warm? Well, let me show you something. So in this space, we have our 8 RAM chips. Watch me turn it on, and we see that they start warming up. See anything unusual? Yeah, so the third one in from the left, the fifth one
6th and 7th are just getting ridiculously like hot. Like if I touch these, I can't hold my finger on them for more than a few seconds because they get really hot. Like right now they're still warming up, but like once I've actually let it sit here for a little bit, yeah, they just start getting like way too hot. Just from like doing a little bit of research, I found out that RAM problems in these things were actually pretty common, but it would appear that there's definitely something wrong with the memory. And some of you guys are probably from the get-go, check the RAM, check the RAM. Apparently, from what I'm gathering, I'm no expert on this thing, I'll repeat once again, but what I've kind of found out is that apparently if you can get this thing to boot from the diagnostic ROM, looks like it will boot to that alone, and then that way you can actually use that to test the RAM, assuming there was RAM present. But I'm thinking, and I try to research to see if anybody's actually, you know, booted one of these things to the diagnostic ROM without any of the RAM present, and I didn't really find anything. But what I'm hoping is that if I remove all the RAM and I get it to boot to the diagnostic ROM, that I can at least get something on the display. Because what it looks like might be happening is, looks like the RAM here is dragging some of the data lines like down, and it's just not allowing anything else to function properly. And one of the symptoms that I found online for having bad RAM was that you get no video or just the black screen, which appears to be what is happening now. Yeah, I'll pull them all off and we'll try it again. Okay, all the RAM's been removed, and using hot air to remove these was actually not really a bad idea. But then again, I'm glad that I baked the board, like I mentioned at the very beginning, that I baked it for like 10 hours or so. None of it delaminated. It's all the holes are in like very good condition. I did have to like straighten out a bunch of the pins on the ICs like before I even started, just to make sure, you know, that they were going to come up like straight up or anything. But after that, like pulling them off, I was able to do it like in like seconds for each one. So it went by like really quick. But I also preheated the board using the preheater plate, so I had this thing hot the whole time, and then, you know, I blasted each chip with like hot air and used the tweezer to pull it up. So I've got 18 to 22 on the keyboard connector, and I got my video connector. I got power, I just haven't powered on the switch yet. I've got that set to composite input. Let's see what happens. Here it goes. And click. Well, that doesn't look promising. Nope, I don't even see anything on the scope there on the video signal. How's that clock looking? Do we still have a clock? Oh, but that's super low. It's like not even 500 millivolt per division. Okay, something's not right. Oh, I'm stupid. Apparently at some point I accidentally switched this to 10x. Whoa, whoa, whoa! Something showing up. I have no idea what's going on. You can see right here on the clock, or on the scope, it's doing something. But what? I had to change this to 4.3 because it was, yeah, I didn't want it to like be cutting off anything. It was set to fill. But yeah, looks like something's going on. So could it be maybe some bad traces somewhere? Maybe there is a broken trace after all. Bending the board doesn't seem to do anything. But whoa, yeah, that's like furthest I've gotten so far. Like I have not been able to get it to do anything like that until now. Okay, so unfortunately I got it to show that video that one time, and now I can't get it to do anything at all. I've tried a bunch of different things. I've even tried just kind of like bending the board here and there, see if maybe, you know, some broken trace or something was the issue, but nothing. I don't see any other broken components. There's nothing like, you know, that I can visually see that looks like it may be problematic. I even did replace the capacitor that I put right here, the electrolytic. I replaced it with the 47 microfarad just to see if maybe, you know, the reset timing was something that was throwing things off. Even though from, you know, what I saw in the schematic, it shouldn't have mattered. It was just basically going to hold the reset down longer before actually allowing the chips to continue operating. The only other thing that I've found that looks like, you know, it's of some significance is if I probe some of the data lines and address over here on the CPU, we see that at first it kind of does this garbage crap up here, but then eventually it like extends outwards. Yeah, there it goes. And then it starts kind of like stretching out, and then it looks like, you know, there's like periods of something there. I don't know if it's like changing address. There we go. So now we've got like just little bursts of, so I have no idea what that means. I think the only way to like pinpoint if there's like a bad IC would be to pull them all off the board and put them, you know, like in a known working board. The problem is I don't have another one of these that, you know, that works or anything. I mean, I don't have another one, period. So that's pretty much a no-go. It would be kind of trivial for me to pull these all off, you know, and like put sockets here. And I could see like if there's like some other underlying issue like underneath one of these chips or something, and, you know, like check all the traces and, you know, check all the resistors and everything. But that would be extremely time consuming and not something that I was even planning on doing. The whole point of this video was not even to be like a repair. It was just to see if we could get this board that has been kicking around in my junk bins for like 20 plus years, because when I took this thing apart, it was like probably like sometime in like the mid 90s. That's how long this thing's been slowly kind of degrading and becoming to be in like this state that it is now. And the other thing is that when I found this thing, I have no idea if it even had any problems to begin with, because I didn't know its history. Like I said, I just found the thing. I didn't have a power supply or anything for it, and at the time I probably wouldn't even have bothered like mess with it much either, because like I said, I always just kind of want to see what was inside of things. Although I kind of vaguely remember when I found it, I think the keyboard was already damaged. I think like someone may have like pounded on it or something, because I think I vaguely remember something about it being broken. So if I were to pull, you know, like all the chips off, I do have sockets for like the 40 pin devices. I would have to get some for the 28 and the 24 pin ROMs here, and I don't have any sockets for the RAM. I'm really glad that the hot air idea here worked with the flux and everything, because I really wasn't looking forward to having to suck a bunch of holes like that, because that's a ton of little pins that I would have had to, like, you know, manually done or used solder wick on. It was just so much easier to blast them all with hot air and pull each individual chip out. It took seconds compared to, I don't know, how long would I have been here, like an hour or more? No clue. So with all that said, I hope that somebody or anybody out there watching that was really hoping to see this thing working, you know, like didn't get like retro blue balls or something. I was kind of hoping to see it working myself. So unfortunately, I think we're just going to have to call this one a, you know, it's kind of a wash right now. It seems like it wants to work, but at the same time, like not really getting anywhere. And it seems like it needs a lot of investigating, and it would help to have a spare just to be able to individually test things. If there's anybody out there that has like any interest in seeing me like do more with this, you know, like seeing if we can like investigate it any further, I mean, do leave a comment below, and, you know, I'll see what I can do. I'm not opposed to the idea of, you know, trying to dig in deeper, because I did, even though I couldn't get it working, I did learn a bunch, you know, just looking up at the schematic and, you know, just like seeing how things were wired on here on the board. I did learn quite a bit, and maybe some of you guys did, you know, learn a little bit too, and that's cool. That's what we're all about. Unfortunately, the schematic did have a few minor differences, you know, compared to what we actually have on the board, but it was good enough to get an idea, you know, of like what we should expect or what we should actually see on here. So once again, thanks you guys for watching. Thanks for all your support, and I will see you guys around the bench.